The developmental disorder known as autism was first described in 1943. It appears in about 5 out of every 10,000 births and occurs more often in boys than in girls. It is found throughout the world in families of all racial, ethnic, and social backgrounds. As recently as the 1970s, researchers believed that autism was environmentally and psychologically based, and that it was caused by parenting style, especially mother-child interactions. This long-held belief brought blame and humiliation to parents of autistic children. It affected the diagnosis of autism, as well as the intervention strategies used in educating and caring for autistic individuals. Among the leading investigators of autism are Dr. Margaret Bauman, director of the Autism Research Foundation in Boston, and her colleague, Dr. Thomas Kempler. Their team has been studying brain tissue at autopsy, hoping to find clues to the neurological basis of the disorder. They compare tissue from people who suffered from autism with tissue from normal individuals. They have found some remarkable differences.
Our research uses a technique called whole brain serial section, and this is a very old technique. It's also a fairly expensive technique and not very glitzy. Basically what we do is we take an entire brain and we embed it in something called celloidin, which firms it up, and it has to sit there about 8 to 10 months until it's hard enough for us to do something with, after which we section it in a very standardized protocol. And we can do this with an age and sex match control as well, so that all of the material that we get is processed identically. We then take that material and we use a comparison microscope, which is basically 2 microscopes next to each other connected by a bridge. And we then can take the same sections out of each brain, a normal and an age-matched an age-matched autistic brain, and we can look at those identical sections side by side at the same field of view, the same magnification, and we can compare. And that's been extremely useful because I think without that technique we would never have found what we found. The brain findings here are very subtle, and they are not able to be picked up by more standard methods of looking at neuropathology. So while this is an old technique and an expensive technique, I think in this circumstance it's the only way that you can survey a brain when you don't know what you're looking for. We didn't have any idea what we were looking for when we started, and I think this is the only way that you can really survey a brain with any kind of comfort. By using the standardized technique, we've been able to identify 2 circuits within the brain. And by circuits, we mean that the abnormalities are not site-specific. That is to say, there are a number of sites that may be at different areas throughout the brain that are connected to each other and which talk back and forth to each other, if you will. Those 2 circuits include the limbic system, which is responsible for memory, learning, behavior, emotion, and the cerebellar circuit, which was in some ways more of a surprise to us at that time. The abnormalities have been found using this whole brain serial section technique, and the abnormalities consist of 2 different abnormalities, actually. The limbic system looks like a developmentally more immature system. It's not brain damage. There isn't cell loss there. In fact, the cells are too many, too small. There are more neurons than we would expect to see, and the ones that are there are too small. And it looks like the system of a much younger person, and not only in terms of the patient's chronological age, but in terms of the rest of the brain itself. The cerebellar circuits look a little bit different in that there are a number of cell populations that are missing. We're not clear whether or not those cell populations arrived at their designated site and then later disappeared, or whether they never arrived in the first place. But it's the population that helps us speculate about when this might have occurred in the prenatal period. So in some ways they're somewhat different, but they give us 2 pieces of information that I think are helpful.
Dr. Bauman's research contradicts the theory that autism is a psychological disorder. Rather, it is associated with brain malfunction. This may be traced to a lack of normal neural growth and development during the prenatal period.
This is not something that happens at birth. This is not something that happens because you were a bad mother. This is something that was pre-programmed sometime early in development prior to the end of the 2nd trimester. I don't think we're in a position at this point to say just when that happens or in fact what the cause is, but we at least can make some estimate about the timing.
I just like them. This is like cattle paradise here.
Growing up with autism doesn't necessarily mean that a person cannot achieve a high level of professional competence. In fact, for one person, it turned into an advantage. Meet Dr. Temple Grandin, a professor of animal sciences at Colorado State University.
Dr. Grandin.
It's a real pleasure to be here today. And just start out, I was very autistic and very messed up as a young child.
Temple Grandin's professional achievement would never have been predicted on the basis of her early childhood. She was 3 years old before she spoke her first words. She was emotionally withdrawn. Doctors recommended that she be institutionalized in a facility for the mentally disabled. But special attention from her parents and teachers enabled her to succeed in school.
Well, the first thing was being put into a really good educational program by age 2.5. I can't emphasize enough the importance of early intervention in autism. I had about 20 to 25 hours a week in a small classroom. I also had a nanny that spent many hours a day playing games with me. It's very important to keep autistic children engaged with the world, because if you let them tune out, they're just going to go deeper into autism and deeper into all the sensory problems. Here in Canada, the two biggest plants in Alberta that process about half of all the feedlot cattle in Canada, they use systems I've designed. So when you go get a steak here in Canada, it's got a 50% probability that it's been through one of my systems. And I don't think that's doing too badly for somebody they thought was mentally retarded and they wanted to send me away to an institution.
Unlike many autistics, Dr. Grandin has been able to overcome the barriers to social interaction. Her progression from social isolation to prominence in her field has been remarkable. It is due in part to her autism and the special way it enables her to view the world.
I think totally in pictures. I don't have any language-based thought. Well, animals also would think in pictures. I think like videotapes in my head. And so it's easy for me to imagine what would it feel like to be a cow in a certain situation.
This special ability to think in pictures allows her to perceive the world as an animal would. Her special affinity for cattle gives her a humane approach for designing cattle facilities. The holding pens she designs have gentle curves to take advantage of the cattle's natural tendency to circle and also to obscure what lies ahead.
Back to where they came from. They're coming on around and they think they're going back to the corral.
Yeah.
When feeling stressed, Dr. Grandin takes advantage of another lesson she learned from observing cattle. She calls it her squeeze machine.
When I got into puberty, I started having very intense anxiety attacks. It felt like a total state of stage fright all the time. I once told a TV reporter, well, it'd be like first time you ever interviewed somebody really big and you were just so scared you just didn't know what to do. That's the way I felt all the time for absolutely no reason. And I was desperate for relief from this. Well, one day I watched some cattle going through the squeeze chute at my aunt's ranch. And I noticed that some of the animals, when they were put in the squeeze chute, tended to relax. And so I thought, well, I ought to try this. So I went and I tried it. And it would temporarily relieve the nervous attacks. Many autistic children seek pressure. I've had parent after parent say to me, my child gets under the sofa cushions, my child gets under the mattress. Therapists will often use pressure, getting under mattresses to help calm down and relax children with autism. So then, after trying the cattle chute at the ranch, I then built a cattle chute-like device that I could get into that would apply pressure, where I could control the amount of pressure. At first, I tended to just sort of pull away from it, but then gradually I learned to tolerate more pressure. When I was a little child, I couldn't stand to be held because I just got this engulfing tidal wave of stimulation just coming over me.
When Temple feels the need to relax, she crawls into her own version of a cattle chute, which she keeps in her study.
Get in here like this. Put your head through here, just like this. And by working this control, I can let a little pressure off. I can put a little bit of pressure on. Well, the things that bother cattle are the same things that upset a person with autism. High-pitched noise, sudden jerky motion. With a hyper-aroused nervous system, I'm just always constantly vigilant. Any little stimuli just sets the whole nervous system off. You know, being an autistic person is sort of like being a wild animal out in the woods full of predators. Stay in here anywhere from 15 minutes to 45 minutes. Sometimes I'll fall asleep in here. A lot of things that people consider important, I don't consider important. People get concerned about having, you know, a gold-plated bathroom, having a corner office. That doesn't mean anything. You know, I'd like to say when I get to the top of the stairway to heaven that I did something of value for society.
Temple Grandin is certainly an extraordinary example of a person able to overcome the effects of autism. But what does the future hold for the countless others stricken by this disorder?
There are many issues that remain to be investigated. I think the anatomy has allowed us to say, yes, there's something definitely wrong with these brains. We now know where that is, and we're comfortable that those findings are reasonably consistent from case to case. But that's not going to help the kids a whole lot. We need to be able to take it to the next step to find out what it is about these brains that is abnormal other than its structure. And in all probability, there is a neurochemical profile that goes along with this abnormal structure. And I think that's, in my mind at least, is the next step, that we need to look at the brain tissue from a neurochemical perspective to try to find out what's abnormal about the chemical profile here. If we can pinpoint that, and it may be more than one thing. I don't know that it's necessarily going to be one neurochemical substance. It may be several, or it may be different proportions in different people. But I think in all likelihood, there's going to be some abnormality that goes along with this abnormal structure. If we can do that, then we can think about some more specific treatments for these children.